Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, while our topic is latent heat. Aim of today's lesson is for you to understand heat as a substance change its own state. While objective of today's lesson is, at the end of today's lesson, you should be able to know what is meant by latent heat, of fusion, and vaporization, and how to use specific latent heat in calculation. So let's dive into latent heat. But latent heat is being classified in two types. We have latent heat of fusion and latent heat of vaporization. So let's go with latent heat of fusion in the first place. So now, what is meant by latent heat of fusion? From the word fusion. Okay, so when a solid substance is heated at its own melting point, remember what melting point is. Melting point is the point at which solid turns to liquid. I mean, solid changes to liquid, solid particles to liquid particles. That is melting point. So when solid turns into liquid, there is a certain energy there that occurs that allows solid to turn to liquid, and that energy is what we call latent heat of fusion. Okay, and remember, at that point of solid change to liquid, at that melting point, temperature is constant. Tell you, temperature is constant. At that point, temperature is constant. So it's only the energy that allows the separation of the particles in solid change to liquid. So now we say latent heat of fusion means it is the energy needed by the particles to break from each other. Solid particles to break from each other and turns to liquid particles. So the specific latent heat of fusion, we have it as L subscript F. Okay, it means that energy needed to change the state of 1 kilogram of a substance from solid to liquid. Remember, we said melting point. Melting point is from solid to liquid. So when 1 kilogram of solid changes to liquid, that is specific latent heat of fusion. Recall that at that point, temperature is constant. That's what we call without changing temperature. So latent heat of fusion equals to energy, that's the energy required to change 1 kilogram of solid to liquid. That is mass. Remember, kilogram is mass. So that is latent heat of fusion. Latent heat of fusion is energy divided by mass. And what mass is this? That is mass of the body, right? Cross multiply. Then we have the energy equals to LF, which is latent heat of fusion multiplied by the mass. Okay, so energy has the unit of joule, while mass has the standard unit of kilogram. So that means LF, which is latent heat of fusion, has the standard unit of joule per kilogram. Okay, joule per kilogram. So let's move into the second part, which is latent heat of vaporization. The same as latent heat of fusion, but what's the difference? The difference is the change. So what's changed here? Vapor. So now, it's the same thing. When a substance is heated at its own boiling point, what is boiling point? Boiling point is when liquid try to change to gas, which we call vapor. So at that point, in liquid particles, those particles are still closely packed. Okay, but when heated at the boiling point, they try to have a relative distance between them. So this relative distance is what occur at the boiling point that allow the water to turn to vapor. So at that point, temperature remains the same while the temperature is 100 degrees Celsius. So the temperature will remain 100 degrees Celsius for some certain minutes before vapor occur. So at that point, the energy that allowed this boiling to occur and the liquid to tend to be vapor, that is what we call latent heat of vaporization. Okay, so we can define latent heat of vaporization. Why it has its own as L subscript V. L means latent heat. This means vaporization. The first one there means fusion. So the specific latent heat of vaporization, L subscript V, means of a substance which the energy is needed to change the state of 1 kilogram. Remember, first one is 1 kilogram of the substance from liquid to vapor. Why this is from liquid to vapor, while the first one is from solid to liquid. So without the change in temperature. So LV is the same as energy over mass. energy over mass. When you cross multiply again, you still have it the same as energy equals to LV multiplied by mass. LV multiplied by mass. Now, your question is, how do we know the mass of the vapor? How do we know the mass of vapor? So this is how to know the mass of a vapor. How do we calculate that? So now let's go to this. Measuring latent heat. Okay, the diagram below shows how you can calculate the latent heat of vaporization of water. So this is how we calculate the latent heat of vaporization of water. We need to know the mass of the vapor. So this is it. At certain points, we need to know the mass of the liquid. Measure the mass of the liquid. Measure the mass of the liquid. So the mass of the liquid is so at a certain point, let's say the liquid has what we call 5 grams. The liquid is 5 grams, right? When it gets to its own boiling point, which is 100 degrees Celsius, the liquid is 5 grams. But after some minutes, let me just say after 5 minutes or 10 minutes or an hour, okay? So after 15 minutes, you can see if this 5 grams stays in 100 degrees Celsius for good 15 minutes, there will be exchange of vapor to the environment, right? That would be a release of vapor to the environment. So that vapor, so for that 15 minutes, now the liquid has changed its own mass to 4.2 grams. So now we measured the liquid after 15 minutes when it has been its own boiling point, which is 100 degrees Celsius, and we have 4.2 grams. That is, a certain amount of vapor has been released to the environment. That is 5 grams minus 4.2 grams, and that would be 0.8 grams. So 0.8 grams, that is the mass of the vapor. The mass of the vapor is 0.8 grams. So that is how to find the mass of the vapor. Yes, because we cannot know the mass of the gas in the environment, but we can know the mass using this method. Calculate or measure the mass of the liquid before getting to 100 degrees Celsius. So at the point of 100 degrees Celsius, what is the mass of the liquid? And after some minutes, how do we calculate the mass of the vapor that has been released? Then you just need to remeasure the mass of the liquid when it gets to its 100 degrees Celsius. Then you know the mass of the vapor. So let's dive into calculation. So we have this question here. Okay, we have a question here. The following measurements are taken. Joule meter reading after 5 minutes. Okay, now we have 60 kilogram. Joule meter. Now, joule meter is used. It's just the energy supply. Okay, energy supply. That's the heat energy. So, joule meter is the heat energy. That means energy equals to 60 kilogram. Energy equals to 60 joules. Mass of beaker and content. Now that means mass of beaker and content. That's the mass of the liquid at that moment. Let me use Mi. That's initial mass is 968 grams. That's the mass of the liquid. But after 5 minutes, when it has been in its own boiling point, let me use it as final mass, MF, is 944 grams. Now we want to calculate the latent heat of vaporization here, which is L subscript V. The first thing we need to do is we need to deduct 944 from 968. That is Mi, that's the initial mass minus the final mass, right? So that is 968 grams minus 944 grams. And that will give us what? That's 24 grams. So now 24 grams. Remember that the standard unit of mass is not gram. It is what? Kilogram. So how do we convert gram to kilogram? That means we are going to divide it by 1,000 because kilo means 1,000. So dividing this by 1,000, then we have it as 0.024 kilogram. 0.024 kilogram. That is the mass of the vapor, 0.024 kilogram. Fine. We have the energy already, and we have the mass of the vapor. Then we'll go back to the formula. Latent heat of vaporization equals to energy, right, over mass. Now, what is the energy? The energy is 60,000. Remember, we have it as kilojoules. So that is 60,000 joules over, what's the mass? The mass is 0.024 kilogram. So to get the latent heat of vaporization, we have 60,000 divided by 0.024. What do we have there? We have it as 2.5 million. 2.5 million. Then this M stand for million. Then remember that latent heat of vaporization is joule per kilogram. Now, what is M? M means 10 raised to the power of what? Of 6, which means as million. So this is how to solve for the latent heat of vaporization. You can use the same method to solve for latent heat of fusion too. All right. So I just want you to note that latent heat is just the energy needed. Okay, energy needed to change 1 kg of a substance to, when we're talking about fusion, then we talk about solid to liquid. And if we're talking about vaporization, then we talk about liquid to vapor. That means the energy needed to change 1 kilogram of solid to liquid without changing temperature, or the energy needed to change 1 kilogram of liquid to vapor, that's vaporization, without changing temperature. So that will be the end of today's class, and thank you for watching. Please don't forget to click on the subscribe button, and we'll see you in our next class. Bye.